Okay, so if you're studying for the 42 Pscine and you have no idea what to do, so basically this is what we're going to do. I'll just record some videos on how to do the all C's from C00 to C07. I'll cover shell, but only after because it's quite short, so there is no need for us to actually try to focus on this. So we'll just create another terminal. Let's do it 42 tutorial. Okay, we go to 42 tutorial and play the ERC00 and we get to C00 right here. Okay, so here we are. I believe you already have the PDF. You can use events. So we get to the first function, ft/putchar underscore putchar.c. I'll use Vim. You can use any text app you want. ft/putchar.c. So the first thing we do is that in C we have to include libraries, which are basically places where we will get our functions. And we'll use UniSTD mostly. Why UniSTD? Because the only allowed function we can use is write, and write is a function from the UniSTD library. So write a function that displays the character passes a parameter. It will be prototyped as follows: void ft/putchar char_c. So void tab, because on Norminet, if you are using Norminet, you have to do a tab after all your pretty declarations. ft_putchar char_c. So we just have to write one single line and they already tell us how to write it. So write one ec and one. And basically what this does is we call the function write. This first one is related to the output. This one right here says that whatever we write is going to be written on the terminal, and we will cover this later. Here is the C, so let's say we have char C, we say that C is equal to H, and then this will print on the terminal H. And this one is the amount of characters we use. Let's say we want to write something like hello, then this number would be 1, 2, 3, 4, 5, would be equal to 5. But since we are dealing only with one piece of character, we use 1. And that's it. This is, let me just cover until 0, 0, 0, 1, 0, 2, 0, 3, 0, 4, 0, 5. Exercise 6 and exercise 7. Then just move ft/putchar to exercise 0. Okay, I guess. Okay. Then I move to exercise 1. ft print alphabet. So again, vim ft print alphabet dot c. Again, we'll include UniSTD, and as well we'll include stdio. Why will we include stdio? Because we'll use the main function just to make it easier for us to understand and to check if our code, if our print alphabet function is working as it should work. But when you commit and when you bash it to the Norminet and to the Molinet to confirm, you have to either comment it or either remove it. So, void, again, tab, ft print alphabet, and then void. So, again, we know, create a function that displays the alphabet in lowercase in a single line by ascending order starting from the letter A. And we can only use write. So we'll use write. Well, first set a character. Let's call it A. And let's say that A is equals to A, and we can't write A equals A because this second A is not related to anything. When we put it under these marks that I don't know the name in English, we are using the ask table, which is basically this table right here. This is the most easier one to understand. The table itself is like this. We don't have to focus on this right now. Minus D, okay. We'll just use this table right here. So basically, when we write A equals these marks right here between A, we are saying that this variable right here, the variable A, is equal to this A right here. We could also write, if you want, that A is equals to 97, because on the ask table, we are saying, we can see that the 97th value is A. But since for us mere humans who do not have the ask table on their minds full time, we can just write it like this to simplify it. Then we use while is a loop, and it's easier to understand when we actually see it in practice. So while the variable A is smaller or equals to Z, and we'll go over this. We'll write 1 again, A this time, because we are using the variable A, and 1 again, because it's just one character, A plus plus. So basically, what are we doing here? We are saying that while A is minus or is less or equal than Z. And why we say this? Because on the ask table, we can see that A is equals to 97 and Z is equals to 122. So we are basically saying that while 97, if you wish, is less or equals to Z, or 97 is less or equals to 122, we will write our variable, which in this case is A, and then A plus plus. A plus plus is the same thing as writing A plus 1. We just make it short by saying A plus plus. So we'll write a character, and then we will increase the value of A, which will be 98, which is equals to B, and then we'll print B. And then A plus plus again, and then it will be 99, we'll print C. So let's see in use. In main, we'll just use ft print alphabet return 0. You don't have to actually care about the return 0, and neither with this printf I'm using here. This is just to make it clear for us to understand. And then we compile it, gcc ft print alphabet. I have an error right there. You just need to fix it on the return. Okay. We compile, we see our code. So just like the exercise, create a function, displays the alphabet in lowercase. This is why we also use lowercase right here. On a single line, again, on a single line, by ascending order from A to Z, starting from the letter A. Easy. And if you are going to send it to the Norminet, what I did, that I just commented, and just for the sake of it, if you don't want to lose some time, I also used to comment this as well. Basically just doing this right here. But this is optional, like you can just remove the SJO, or you can just remove the main function. It is just easier when you are explaining to your peers, when someone is checking your function, for you to explain it better for them. So we get out, ls, we go to exercise 2. Exercise 2, we need to print the reverse alphabets, the same thing but reversed. Now for the function, displays the alphabet in lowercase in a single line by descending order starting from the letter Z. So again, vim ft print reverse alphabet dot c. We include unistd and we include stdio. we see how the function is prototype, void ft print reverse alphabet void. Cool. So the last time, let's use character Z because it starts with Z. We started with A, now we're going to start with Z. And Z is equals to Z. Let me see if I still have... Okay, we still have our ask table here. So while Z is greater or equals than A, and why Z is greater? Because it starts at Z. I forgot this, okay? While Z is greater or equal than A, because we can see that Z is 122, A is 97, while Z is greater, what we're going to do? We're going to write, again, we use Z this time and only one character at a time, and Z minus minus, you can probably guess Z minus minus the same as writing Z minus 1. It's just easier for us to write Z minus minus. And here's our function. We can just test it on a main function. We call it ft print reverse alphabet print counter slash and turn 0 just for the sake of it. Yeah, we save it. GCC. And there it is. We print all the alphabet on a single line from Z to A. And when Z is greater than A, the while loop stops. And we get our program right here. And again, we can comment all this function. And then we can just comment this as well, like this. WQ to save and exit, and exercise 2 is done. CC. Okay, ls, we go to exercise 3. Print numbers. Okay, so again, we will display all the numbers on a single line by ascending order. Let's just go to our vim, print numbers.c, include on lowercase unistd dot h, include stdio. How do we prototype? Void ft print number void. So you can already expect this char a, but you can use any letter you want. You can say like char numbers, for example. I just like these letters. Now, the thing is, we'll say that A is equals to 0. But why can't we use 0 like this? Because, well, as you can guess, even the numbers have their own, even numbers have their own numbers on the ask table from 48, which is equals to 0, until 57, which is equals to 9. So we will also have to make it a string, which is a character between these marks right here. So while A is less or equal than 9, because the numbers are just 1, 0, 2, 6, 7, 8, 9, we can make any number with this 9 just right there. We will write 1, A plus plus. We'll go to our main function. We tested ft print numbers. We'll also break a line here. Compile it. I forgot to make an F right here. Print F. Zero, 1, 2, 3, 4, 5, 6, 7, 8, 9, and there we have our function. Again, let's never forget, we make it a comment. Again, make it a comment here, or you can delete it. You can choose what to do with it. WQ, okay. Next, FT is negative. So we are finally actually starting to do some 20-year code right here. We do our vim ft as negative dot c include unistd include stdio. Create a function that displays n or p depending on the integer sign entered as a parameter. If n is negative, display n. If n is positive or no, display p. Here's how it should be prototyped. Okay, so void tab ft is negative int n. So you can already see that differently from our programs until now, besides the right, we have an int here. And what does it mean? It means that when we are writing our main function, when we are going to call this function, we need also a variable inside it. We cannot say ft is negative and do it like this on the others, just like we did on the print numbers. Why? Because on the print numbers, right here, we had a void, which means this could be empty, which means that on the main, this space here could be empty. But now it's not a void. Now we have an int there, which means that we'll have to have an int right here, and it may be anything. We'll get this later. Ft is negative. So basically what we are saying, well, it will write p or n depending on the value of p of n. So if we have our n right here is positive or no, which means it is greater or equals than 0, because 0 is no, we'll write p. And it's very important because Norminet is, you guys know how Molinet is, I guess. It is a upcase, like big case, I guess. It's upcase, how you say it. It's a big P. It's not a lowercase p. It's a big P. Well, if n is greater or equals than 0, we'll write p. Or else, we'll write n. And this is our program. Now we can test it on a main function. Int main, we'll say that int n is equals to 5. And on the main function, we don't need to use the Norminet rules, which say that we have to first create a function and have a tab right here, and only then declare it, because this is our main function, and we'll not use it on the code itself, because it will just be a big comment. So we have int n equals 5, and then we'll just print it. So print, no, I am being stupid. Ft is negative, and then we'll say n. We don't have to write int n because we already, their program already knows it is an int. And then again, just for this, for our visual sake, let's break it, let's compile it, and here we have, because 5 is greater or equal than 0. And now it is a good practice for us to always check if there is nothing wrong with our program. It is equal to 0, so it is p, and then let's see, a minus right here. We have to compile it again every time we change our code, and negative. Our code is working just fine. Let's go to the next one, which is the first nightmare of the Pscine, the ft print comp. At least it was my first nightmare. Exercise 5. Create a function that displays all different combinations of 3 different digits in ascending order, listed by ascending order. Yes, repetition is voluntary. Here's the intended output. 0, 1, 2, 0, 1, 2, 3, 0, 1, 4, and then 0, 23. What is it that we are looking? It means that we will never have a number that will repeat themselves. Why? Because repetition is voluntary. 987 isn't there. Why? Because 789 already is. Meaning, the numbers will not repeat themselves, never. And 99 isn't there because the digit 9 is presented more than once. So we can already imagine how it is. So we won't have 000 or 001 because the 0 repeats itself, neither 011 or 031 because I already have 0, 1, and 3 in this order right here. So let's start it. fd print const.c, include unistd, and include stdio. So let's prototype fd print com void. So in this case, we'll use 3 variables. We'll use characters a, b, and c. And we'll say that a is equals to 0. So, no, sorry, a will be equal to 0 in this case, because it's a character and you will see it throughout the code. So, while a is different than 7, because the biggest number for a is 7, if you don't understand, if we have 1 to 3, we'll make it ABC. So a is equals to 1, b is equals to 2, and c is equals to 3, or in this case we have a here, a, b, and c. I hope you guys kind of understood what I am trying to say. So, and while a is and why 7? Why a different? This is the code symbol for different than 7. Because the biggest number a can get is 7, because the biggest result is here, 7, 8, and 9. So the biggest values for a, b, and c is 7, 8, and 9, accordingly. And we'll say that b is equals to a plus 1, because this is basically 1, but it's just a better example, because if we change the value of a, we will not need to change the value of c and b. Again, this would be a waste of time. We just say a plus 1. And while b is different than 8, again, we open and close it, while c is different than 9. Okay. While this happens, what are we going to do? Well, we'll basically write them. We'll write A, we'll write B, and we'll write C. But there's something interesting to note here. You see, they are separated by a comma and by a space. So we also need to separate it by a comma and by a space every time a number finish. So if A is, oh damn, my bad, I completely fucked up. This is lesser than, yeah. If A is different than 7, or these two up bars here means or B is different than 8, or C is different than 9. What are you going to do? We'll write 1, and then we'll have a comma and a space. Now 2, because we're using 2 characters here, a comma and a space. And then we do C++, because as we see the C, as we see the first, the first is the C that increases until it reaches 8, until it reaches 9, sorry, and then it goes back to 1 to 3. So C is the first thing to increase, and then B, and then A. So let's see our code. If we did everything correctly, we have ft print com. Since there's a void here, we need nothing between the braces. I think it's braces how you call it. Let's just make a break line to make it more pleasant for our eyes. GCC, we compile it, and I missed something up, mostly because I messed up here. Let me see if I am correct right here. Let me just get my sheets right here. So A is equals to 0, lesser 9, 1, while A is equals to 0, equals 1. Oh, yeah, we didn't say how, we didn't set the value for C. C is equals to B plus 1. Okay, yep, there it is. So here is our function. So as we see, 012, 013 separated by a comma and a space until 019, and then 023, 24, 26, etc., yada, 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 until we reach 789, which is the end of our function. So there we have it. And then again, we have ft printcom2, which the first time I saw it, I was pretty messed up off my head. So vim ft printcom2 dot c includes unistd include stdio dot h. Cool. Now what do we have? Create a function that displays all different combination of 2 digits between 0 and 99. Listed by ascending order. Here's the expected output. So we have 00 space 01, then separated by a comma and a space. 00 space 02 until we reach 98, 99. And here's how it should be prototyped. So let's go to it. We have void ft print com2 void. So we'll follow the same logic as our last exercise, but in a different way. The first thing is that we only use 2 characters, A and B. Let me just do it like this. Okay, and B. A in our case will be equal to 0 and will not make it 0 like this. Why? Because as you see, first we were only using 1 character, it would only be 0, 1, 2, 3, 4, 5, 6, and 7. But now we are dealing with a 2-digit right here. We want it to be 0, 0, and we want it to reach 98. Because as you can already expect, 98, 99 will be A and will be B. We don't need to make A, B, C, and D. And this is why we are not using it like a string, not like a character, but like a number itself. A is equals to 0. So while A is lesser or equal than 98, then we'll set the value of B. B is equals to A plus 1. And while B is lesser or equal than 99. So what do we have here? We have 98 and 99. So we have to write it. But something we can do, and I will explain why we are doing this later, is we'll already call our first function that we did here, ft put char. So let's do void ft put char c, right, 1, C1. And why are we going to do this? Because since we are going to use the write function a lot of times, and it is troublesome to keep writing all of this, we can simply write ft underscore put char. So ft underscore put char. Now, what are we going to write? As you can see, we can, not as you can see, you can't see it yet, but basically something we can do is that we can write a number, for example, with 2 digits. We can break it into 2 different digits. We can do it like this. So we basically separate a 2-digit number. We transform it, we make it be a one digit number, but that just happens to appear twice. And how do we do this? We basically divide it by 10. Because if we get, for example, 95 and we divide it by 10, since it is an integer, and what does it mean? Integer. What does it, it means it is a real number. It's not 1.55. No. Well, basically integers are whole numbers. It's not 1.55. This would be a float, which is a type of character. It is an int, not a float. So it only works with full numbers. If we divide 95 by 10, we'll just have 9. So this is the first thing that we are going to do right now. We are going to say that the first is a divided by 10. And you can say, okay, we'll get the first character, which is 9. But then we'll also need the other 9. Or on our first case, the other 0. How do we get this other 0? Well, we do ft char a percentage of 10. This percentage is the rest of the division. So we have, for example, 95 percentage of 10. Well, since the division will get the 9, you can guess that this percentage right here will get the rest. And the rest of this division is 5. So this will basically get our first 0 and then our other 0. And then we have to write a space between them so they don't get all together. It's not like 0, 0, 0, it's 0, 0 space 0, 1. So ft put char, this time b divided by a, b divided by 10, sorry, and ft put char b rest or percentage of 10. Code. Now we have to divide it by a comma and a space. We already know how to do it. If a is different than 98 or b is different than 99, right? Or ft put char. I prefer to use right because then we can directly on the code itself declare that it has 2 characters and not 1. So comma space to right here, and then we iterate b++, and then a++. So then we have our main function right here to see if we didn't mess up with anything. ft print on 2. There's a void right here to break the line. Return 0. We compile our code. ft put char on line 19. Let's go to line 19. Put char. We compile it again. No mistakes. I did something wrong. The commas and the spaces are cool. Let's see where I messed up. B is equals to a plus 1. Oh, yeah, of course. I forgot that we have to... Okay, this is kind of weird to understand now that I already explained it. Why am I on print column? Okay, so what I forgot to say, because I was stupid, is that we declare that a is equals to 0, but if we get our ask table, we'll see that 0 is null, and that's why it wasn't showing anything. So in order for us to actually write it, we'll have to include... okay, I already know what I did wrong. So in order for us to actually make it like a character, we have to put a 0 like this plus a. And why is it this? Because this will get the null, and then we'll sum it with the value of 0, which is 48, if I'm not mistaken. As u minus the 48. Yeah, so basically add 48 in order for it to become a character of numbers. And we'll do this. Sorry for the coffin. And we do the same thing right here. Oh yeah, perfect. So here we have our code that starts from 00, 02, 03, 04, all the way until, let's find it, 0098, 0099, and 0002, until again we reach all the way to 9899. Pretty amazing, isn't it? I hope you guys understood the concept, but we have to put this 8 basically to transform this division right here into a character. This is why we put the 0 right here. So this would be 0 divided by 10, 0. We sum it with 0. You can basically, if it is easier for you, you can sum it with 48. But I prefer like this because it is easier for a normal person to understand this code better. But here we have our print comp 2. I will not cover print comp n because this is just to make it easier for you. And if you just basically on the last exam and on the third exam, there are the most important ones. This FT print comp n will not fall into, and if it does, it means you are already far enough to get into the 42 program. And well, if you proceed to actually create a good concept for yourself of how all of this works, you can basically do print comp n. I'm just doing this for the ones that need to understand the concepts and want to learn, because I could just come here and put my GitHub link and just say copy and paste the code. I'm here to kind of explain it to you. That's why I'm losing time. But anyway, so let's go to exercise 7. Vim fd put number dot c include unistd include stdio. So create a function that displays the number entered as a parameter. Okay, cool. The function has to be able to display all possible values within an int type variable. Here's how it should be prototyped. For example, ft put number 42 displays 42. Now this is interesting, and why? Because as you can guess, int, this is going to sound a little bit about computer engineer right now, but I'll try to make it easier for us to understand. Basically, an int has a value of bits. Why? Because every time we write a number, let's say we write 5, the computer has to understand this 5 and has to put it in a memory somewhere, right? So let's, for example, on the brain, I say to you that my name is, I don't know, Cristiano Ronaldo, okay? So you have a variable that is my name equals to Cristiano Ronaldo. And then you put it somewhere on your brain, but your brain needs memory. Yeah, like if you have a brain full of thoughts and full of things to think, you don't have space to put it on our brain. Technically we do, because our brains are much better than a computer, but the computer brain, the computer's brain does not have infinite amount of space, and it doesn't forget things like we do to clear our memory. It knows everything it has. So if we say int equals to 5, we'll have a certain amount of bytes on the computer it's allocated. On the int case, it's 4. On the char case, every character has 1 byte of space, but every int has a 4 bytes of space. And then you can ask, okay, so how much space do we have on an integer? Well, on the average int, we can get the space by writing get conf on uppercase int max, int underscore max. So this, ladies and gentlemen, is the biggest possible value of an int, which is 4 bytes multiplied by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers, which would be 40 bytes. This is the biggest value we can get of an int. And then we can get the minimum of int, which is minus 22, 47, 48, 36, 48. And yeah, you can notice it is 1 byte bigger on the negative side than on the positive. It is what it is. So actually, if we start to think that the minimum is not 0, is actually minus 21, all of this up to 21, 47, etc., 47, we understand that we have a big range of numbers to work with. So, how do we go from now on? Well, you already know that we need to display all possible values within an int type, so it won't be bigger than 21, 47, 48, 36, 47 on the positive, and minus 21, 47, 48, 36, 44 on the negative side. So how do we go from here? Well, the first thing we do is we start with a putcher void fd putcher right char c right 1 c and 1 again, because we are going to write a lot of stuff and it will just make it easier for us. And now I go to the function itself, fd put number int and b. Now, the first thing we need to cover is the negative side because it's bigger. So, if our NB is equal to, you don't have to memorize it. I just gave you the code. You can like get conf int min. I just did my good, since I redid this exercise so many times I already have in my mind. Minus 21, 47, 48, 36, 48. What are we going to do? Well, the first thing you're going to do is we're going to print, or you're going to display, or you're going to write, whatever you name it, fd putchar, the minus symbol, and then fd putchar, the 2. And then we can simply say that nb is equals to 1, 47, 48, 36, 48. And this will print nb because we'll write nb at the end. Now, the second thing you need to cover is when the number is negative. And by the way, you don't have to worry if nb is like minus 9999999, etc., because the program itself, the computer itself will say, this number is too big, I can't handle it, I don't care about it, car bumped, fail. So you don't need to stress over it. If the number is less than 0, what are you going to do? Well, we'll simply write fd putchar minus symbol again, and we'll say that NB is equal to negative NB. Pretty simple. And now we have to cover when NB, if NB is greater than 10, is greater or equal to 10, we will repeat the program with ft put number, and there's a lot of understanding on why it is put number right here, but basically it is a recursive function. We'll have more recursive function and I will explain it better then, but basically NB divided by 10, just to make it clear for you. Let's say we have the number 777. So the program will keep going all the way until 777 is not divisible. I don't know if this word exists, but anyway, it's not divisible by 10. And then we'll cover the last digit with ft put char 0 plus nb percentage of 10. And how does this work? Well, let's say we have 777, then we'll do ft put number nb divided by 10. And then this number will become 7, and this will be NB 77. And this 77 is not anywhere. But then the program will run it again because NB is still bigger or equal to 10. As you can see, 77 is equal to 10. So this will be again 77 and 7. 7 is not bigger or equal than 10. So the program will go the other line. And then we'll have just 7, and we'll get the 7 on the NB variable by getting the rest of the division with 10 and summing it with 48 or with the character 0. Now we can go to our main function, and we'll create an int NB, say that is equal to 21, 47, 48, 36, 48. And then we'll just use ft put number nb, and we'll return 0. So let's compile, and there it is, 21, 47, 48, 36, 48. Now, for the sake of it, and just for you to understand better, if I put 49 here, which is a variable that is not covered by int, the program doesn't even let me compile because it has an overflow, minus w overflow, meaning that this number is bigger than an int variable, than the max value of int. So it doesn't even let me write it. As the same thing as we have 21, 47, 48, 36, 47 on the positive. W, GCC, ft put number, everything is cool. But if we put 48, the program okay, this wasn't supposed to happen, but I guess 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, okay, now it deals with overflow. Oh yeah, because I did that 122.50. Okay. Okay. Yep. Well, never mind then. Just forget about my explanation. There is an overflow. Some way it is not following the max here. But you know, welcome to programming. But yeah, if you want, you can leave 42 and let's test our program again. It's important to test our program every single time I make a change to make sure it is working clear. So this was C00. Again, I will not cover this because my goal with making this video is not for you to ace the Pscine. This is useless. Maybe you already see from my videos, but I'm only covering until C07. I'm not planning because you don't need to go further than this to get on the Pscine, like until the until you get to C07, you might face some challenges on the exams, on the second, the third, and the last exam. The first one is not important. You can even not go, but it's very good for you to go, for you to understand how the exam work. But 95% of people on the 42 program enter the didn't enter the first exam. Didn't even enter the first exam. They didn't try it. Okay. So yeah, I won't cover all the C's. There are 12 C's. I'll just go to C07, and you have to understand it. You cannot go to my Git. I'll put it on my GitHub as well. There's probably a link below. But you can't just copy paste the codes and not be able to explain. This would be stupid. So I will try to explain my codes for you and my train of thoughts when creating them. I already created all these codes you can see in my other videos I was studying for the Pscine. I don't say anything, it's just like me programming with music and ChatGPT to make me understand code and GitHub and me staring at my screen for 30 minutes straight. But yeah, basically this is it. Until C01, goodbye, woohoo. Oh, good 42 for you. I hope everything is going fine. Make friends and create a WhatsApp group or a Telegram group or any group. It's cool for you to have and take photos. You will want to remember all of this. Bye.